Every second of every day, modern businesses generate a tidal wave of transaction records, marketing metrics, and operational logs. But raw information on its own is effectively useless. Without a way to process it, billions of individual data points just look like static to the human brain. If you try to solve a complex problem, like calculating exactly how many pounds of coffee beans a regional cafe should order next month by crunching the numbers by hand, you run into an immediate bottleneck. It takes hours of manual arithmetic, and a single misplaced decimal ruins the entire calculation. This creates a massive vulnerability. When businesses cannot efficiently process their own information, they are forced to fall back on intuition and guesswork rather than mathematical certainty. Surviving in this environment means closing the gap between chaotic raw inputs and actionable strategy. And the accessible analytics tools required to do exactly that are likely already sitting on your desktop, hiding in plain sight. The first step to making sense of the chaos is a phase called descriptive analytics. The entire goal here is simply to answer one question: what is currently happening in the business? You don't need a massive enterprise server to do this. Everyday spreadsheet software like Excel has quietly evolved into a robust analytics engine capable of handling this phase at scale. The pivot table takes chaotic rows of raw data and collapses them into a clean, categorized matrix. You simply drag and drop specific data fields, like sales reps or regions, and the software dynamically builds an interactive report on the fly. Suddenly, you spot rising performance metrics, shifting geographical trends, and immediate anomalies, all without writing a single complex formula. By summarizing the noise, descriptive analytics gives operators the baseline clarity they need to understand their current state before they attempt to change it. Once you know where you stand, you can move to the next evolutionary step: prescriptive analytics. This shifts the focus away from observing the past and toward mathematically dictating future actions. Let's go back to that monthly coffee bean order. Instead of guessing how much to buy, we can use an optimization tool, like Excel Solver, to calculate the absolute most cost-effective purchasing plan. We first feed the tool variables, mapping fluctuating wholesale costs and expected customer demand. Next, we set strict mathematical constraints, like maximum budget and physical storage capacity. The software evaluates thousands of ordering combinations in seconds, replacing hours of grueling manual arithmetic. The final output is a definitive answer: the absolute best, most profitable purchasing solution available within your specific limits. By removing human intuition from the equation, prescriptive analytics processes the specific variables and constraints of a problem to deliver a definitive, optimal plan of action. When you take that kind of precision and apply it beyond a single purchase order, you enter the macro-level discipline of operations management. Organizations deploy these descriptive and prescriptive tools simultaneously to oversee massive multi-tiered inventory networks across the entire company. This line graph maps out a historical data trend. By using built-in forecasting functions, managers can synthesize this past performance and generate a predictive trend line to accurately plot future inventory volume over time. With a clear view of what's coming, managers can proactively allocate their resources and optimize production schedules well before a supply chain bottleneck ever occurs. Project managers rely on these exact same visualizations to monitor overarching budgets, track long-term milestones, and ensure that sprawling initiatives stay strictly within their required limits. Strategic analytics replaces manual, error-prone arithmetic with a system where complex operational decisions are mathematically verified in seconds. Mastering these analytics tools provides the fundamental mechanism for engineering a data-driven culture, letting data handle the computational heavy lifting required to drive growth and reduce costs.